Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So today we continue our lesson on Introductions to Scientific Programming, Chapter 9 Matrix Algebra. So today we will learn about part 2 for this chapter. Okay, let's continue. Okay, so today we will first learn about cross product. So how you want to create a cross product inside MATLAB. So for example, given any two vectors of a and b and theta as the angle between them, the cross product of the two vectors is defined as c equals to a cross b. Okay, or it can be defined as the magnitude of c equals to magnitude of a dot magnitude of b sine theta. Okay, so it's actually C is perpendicular to A and B. So later on when you are learning about a subject of EMT, electromagnetic field theory, so you will learn about all of this cross product. Okay, so I think you're also learning about the cross product on your engineering mathematics subject. Okay, so the direction of C is given by the right hand rule. So this is the right hand rule. So you can see here is that A is directed towards the front of you, B is directed towards the left, okay, if you are standing straight, and A is actually the cross product of this is C actually the cross product of A cross B. So C is perpendicular to both A and B. Alright? Okay, so in MATLAB, when you wanted to initialize a cross product, you need to use a function called cross. Okay? Alright, so let's take a look at example number 7. Okay, so this is actually a part of the EMT subject. Okay, so when a wire of length L carries a current I through a magnetic field B, the magnetic force F by the field on the wire is defined as F equals to I, which is the current, multiplied by L cross product B. Okay, L and B is actually the position. Okay, and you can also use as the magnitude of F equals to I with the magnitude of L cross magnitude of B, or you can use the dot product. Okay, F force equals to I multiplied by the magnitude of L dot the magnitude of B sine theta. Alright, so you have these two options, equation number 2 or equation number 3. So if you wanted to use a cross product, you can use equation number 2. And if you wanted to use a dot product, you can use the equation number 3. Alright, so to compute the magnetic force F, we can either use cross product, equation number 2, or dot product, equation number 3. So below is the MATLAB code for both methods, where using cross product gives a simpler code. So basically, when you wanted to get the force of magnetic fields, okay, you can use cross product. And using cross product is simpler rather than using the dot product. Okay, so you can see here this is the equations of L, B, and I that has been initialized. Okay, and then the first option is you are using the cross product. So the cross product is LB equals to cross LB. So LB is actually the cross product of L and also B. Okay, and F, which is the force, equals to I multiplied by the LB itself, which is the cross product of LB. So you can see that it is simpler. Okay, so for this example, you can also see that we are using the norm. Norm is actually a function to compute magnitude of a vector. So in magnetic field, a vector consists of two data, magnitude and also the direction. But this equation in calculating force only required a magnitude, so we are using norm functions. Alright? Okay, so let's take a look at the second option where we are using a dot product methods. So for dot product method, first you need to calculate the theta. Okay, so for cross product you don't have to calculate the theta. Okay, but for dot product you need to calculate the theta for this example. Okay, so the theta has been initialized as cos inverse dot LB normalized L multiplied by norm B, and this is the function. This is the equation of the force. Okay, I multiply by norm L multiplied by norm B multiplied by sine theta. So you can see here that the dot product for magnetic field force will become much more complicated. But it just give the same answer as the cross product because the equations has two options. Either you wanted to use a cross product or you wanted to use the dot product. Okay? Alright, next we'll take a look at the matrix inverse. Okay? So matrix inverse properties. So inverse of a matrix A, though written mathematically as A to the power of -1, is not actually equals to 1 over A. Okay? So you must know what are the differences. A to the power of -1 is not equals to 1 over A for matrix. Okay? So if an inverse of a scalar multiplied with the scalar is equals to 1. So it means that when the inverse of A, so A to the power of -1 multiplied by A will become 1. Okay? So the multiplication of an inverse matrix to the original matrix is an identity matrix. So it means that when you are multiplying inverse matrix multiplied by the normal matrix, so the matrix must have the same, must consist of the same variables. A inverse multiplied by A must equals to the identity matrix. Okay? So inverse of a variable multiplied by that kind of variable will become identity matrix. Okay? So only square matrix of similar rows and similar columns, M times M, has an inverse matrix. Okay? So if the size is not the same, the number of rows is not the same as the number of column, it doesn't have any inverse matrix. Okay? And also the singular matrix does not have an inverse. Okay? 1/1 matrix doesn't have any inverse. Okay? So MATLAB offers three approaches. Okay? So the matrix inverse function. So the first option that you can use is the inverse function INV. Okay? The second approach, you can also raising a matrix to the -1 power, A the power of -1. Okay? And the third option, you can also use a left division operator. Okay, so this is the left division operator. So for normal division, it is right division operator, but this one is left division operator. When multiplied with a column vector, for example, A inverse B, where B is a column vector, can be written in MATLAB code as A left division operator B. Alright? Okay. So let's take a look at example number 8. Okay? So in example number 8, okay, we initialize different type of option that you can do to inverse a matrix. Okay, the first part is inverse A using inverse function INV with the bracket of the matrix. You want to inverse it. Okay, the second option is you make A to the power of -1. Okay, and the third one is A with the left division operator. Okay, so this is actually A inverse multiplied by 1 transpose. Okay, so usually when we wanted to multiply the value of the inverted matrix, we are usually using the left division operator. Okay, because it is it is become more easier for us to detect. Okay, so we are using the left division operator if we wanted to multiply the inverse value with other value. Okay, all right. Next is all about determinant. So I'm sure that you already learned about determinant in your engineering mathematics, right? So determinant is a useful value that can be computed from the elements of a square matrix. Okay, so it only applies on a square matrix. So the determinant of a matrix is denoted as det, okay, det or A with the magnitude, if I'm not mistaken. Okay. Alright, so for 2 by 2 matrix, the formula for the determinant is, so when you are learning about the determinant in your engineering mathematics, you can initialize as AD minus BC. Okay, so this is how you calculate the determinant of a matrix. Okay, so example number 9, so when you have a matrix with 2 by 2, you can just multiply it simply, okay, to get the determinant. Okay, so next is checking a singular matrix. Okay, a singular matrix is a matrix that does not have an inverse. A matrix is said to be a singular matrix if its determinant is equals to 0. So when the questions ask you to check, okay, is this matrix is a singular matrix? So what you should do is you should check the matrix either its determinant is equals to 0 or not. Okay. So for this example number 10, so we have the first matrix called matrix A. So if we wanted to detect either the matrix is a singular matrix or not, so you can just detect, or you can just create, or you can just find the determinant of a matrix by typing det, which is determinant, with the bracket of the matrix that you wanted to have. So this is how we wanted to find determinant of a matrix. Okay, so for this matrix, the determinant is equals to 0. So it means that it is a singular matrix. So what singular matrix does is it doesn't have any inverse. Okay, so when we are using the inverse function of A, it will become infinity. Okay, because the matrix is singular to working precision, so it doesn't have any inverse. Okay, although that the size of row and columns is similar, but it doesn't have any inverse because it is a singular matrix. Okay, in order for you to detect either it is singular or not, you can just detect it by using a determinant. If determinant equals to 0, it is singular. If it is not, it is a normal matrix. Okay. Alright, so now let's take a look at the example of the area of a triangle. Okay, so the area of a triangle can be formulated using matrix determinant as below. Okay, so right now this example is used to calculate the area of a triangle by using determinant. Okay, where T is the matrix of a Cartesian coordinate of the 3 corners of the triangle. Thus, matrix T is set as below. The first column is the x coordinate, the second column is the y coordinate, and the third column is set equals to 1 to form a square matrix. Okay, so for this, okay, in order for us to use determinant, we must have a matrix with equal rows and equal columns. But we only have 2 data of coordinate, which is x and y. Okay, so in order for us to create a square matrix with the similar rows and column, you can just put 1. Okay, all right, so this is the codes for you to calculate the area of a triangle. Okay, so first you are initializing the matrix T, okay, which consists of x and y coordinate and also an additional 1. Okay, you can just create by using by initializing the variables T with the matrix. Okay, we are learning about this in chapter 2 if I'm not mistaken. Okay, alright, so you create this matrix and then A equals to ABS. Okay, ABS is actually like a absolute. Okay, absolute is actually like this one. I'm sorry, it's not absolute, it's like a positive. Any value which is negative will become positive. Okay, absolute 0.5 multiplied by the determinant of T. So this is a matrix T. So this is how we wanted to calculate the area of a triangle by using determinant. Okay, so you must know how you wanted to use determinant and what are the application of the determinant in solving engineering problems. All right. Okay, next is the example of the sets of linear equations. Okay, so one of the common linear algebra problem is finding the solutions of a linear set of equations. For example, you have multiple equations like this. Okay, 4x1, 5x2, 6x3, and so on. Okay, but you wanted to find the value of x1, x2, and x3. Okay, so previously we are learning about engineering mathematics to find x1, x2, and x3 by using your scientific calculator. But you can also do this by using MATLAB. Okay, how to do it? Let's continue. Okay, so these linear equations can be written in a matrix form as below. So previously you already learning about the dot product. Okay, the dot product is actually the summation of the multiplication. So it means that for x1 plus 5x2 plus 6x3 equals to 232. Similar to the second rows, the third rows. Okay, you're already learning this inside your engineering mathematics. Okay, all right. So then x can be solved by multiplying the inverse of matrix A with y as follows. Okay, so when we wanted to move A from here to here, okay, we must the y must be multiplied by A negative 1. It's like an inverse of A. Okay, so what we do here is x equals to A inverse because we wanted to move A here. Okay, and then what we wanted to does here is that we wanted to find the value of x. Okay, so x equals to A inverse y. Alright? Okay. Alright. So in MATLAB, so the preferable solution is found by using the matrix left division operator. So as I've been mentioned to you before, there are several options of doing the inverse, okay? But the most preferable is x equals to A with the left division operator y. Alright? So it is the most recommended for you because you can see what is the exactly operation of A. So A inverse multiplied by Y. Okay, because you wanted to move A from here to here. Okay, all right. Okay, so this is actually the MATLAB code for the previous slide, so I already mentioned it to you. Okay, so we initialize the variables A, okay, and we initialize the variables Y. X equals to A left division operator Y, so A inverse Y. So this is how you wanted to calculate the value of different unknown variable, okay, inside your matrix algebra linear equations. Okay. Alright, so the next example is the circuit analysis. Okay, example 13. Okay, so you are given this circuit. Okay, in analyzing the above circuit, current on loop 1 and loop 2 can be computed based on two equations. Okay, so they are given you the equations. So right now they wanted you to find the value of I1 and I2. Okay, so you're already learning it in your electrical technology subject. Okay, so you must know how to create these equations. Okay, all right, based on this circuit. Okay, so in order for you to find I1 and I2, you can just use the similar option or the similar way based on the previous example. Okay, so by using matrix algebra, I1 and I2 can be simply solved as below. Okay, I1 and I2, and then this matrix is actually over here. So if you wanted to move to over here after the equal sign, you need to inverse the matrix. Okay, and then you multiply it with the 10 and negative 20. So this example is actually similar to the previous example. All right. Okay, so this is the MATLAB code. So it is just a simple code. Okay, you initialize the value of R, you initialize the value of B, and then you inverse R by using left division operator. R inverse multiplied by V, or you can also use inverse R multiplied by V. So you can just use what do we call any type of option, but the most preferable is this one because you can see what actually the operation that you have inside your inverse matrix. Okay, R inverse V. So it is direct. So it's for this one it is like a little bit complicated, but it depends on you because it actually giving the same answer. Okay. Alright, so next is some of the useful matrix functions. Okay, so this is the list of some of the useful matrix functions. So you can just try by yourself, okay? And you can see what is the function of this matrix. Alright? Okay, so let me give it to you some of the example of the useful matrix function. So the first one is the trace. So the trace is actually it wanted to calculate or to sum the value of the diagonal matrix, the main diagonal matrix. So when we can see the definition of trace function is to compute the sum of the elements on the main diagonals. So main diagonal is here, 1, 5, and 9. Okay, so when we put trace matrix A, 9 plus 5 is 14, 14 plus 1 is 15. Okay, all right, so next is I. So let's consider the equation of fx equals to x plus ax plus bx. So where a and b are 2 by 2 matrix and x is a 2 by 1 vector. Okay, so this is the, actually it is not a single number, it is actually a matrix. Let's consider. Okay, so instead of having two multiplications, the equation can be rearranged to have a single multiplication as below, where I is a 2 by 2 identity matrix. So having less multiplication will make the operation faster. So to make the operation faster, you can do it to become one what we call a single multiplication, either instead of multiple multiplications. Okay, so what you should do is you should replace x plus ax plus bx. All of these are multiplied by x, right? But in normal mathematics, we replace this one as the number 1. But in matrix, you cannot do that. Okay, what you must do is you must put it an identity matrix. Okay, so x multiplied by identity will become x multiplied by a will become ax, x multiplied by b will become bx. Okay, so above equation will return wrong result if scalar value of 1 is used instead of the identity matrix. So if your question is a matrix, you must use identity. Okay, you cannot use 1. Okay, because it is a matrix. Okay, so I is a MATLAB function to create the identity matrix. So basically, I is a function to create an identity matrix. Okay, so this is the example of I functions. Okay, you have a, b, and x. Okay, and then you have the equations of x plus x multiplied by a plus x multiplied by b. Okay, so first you wanted to find the identity matrix of the insert I is 2, the size 2 by 2, 3 is 3 by 3, 4 you put 4 here, it is like 4 by 4. Okay, it is used to create the identity matrix. Okay, so next is the example of putting the correct value for matrix. Okay, so the next one is x multiplied by I. So it means that we put identity matrix here. So the second option is x multiplied by the number 1. So you cannot put the number 1 here because this is the matrix operation, not a singular number operation. Okay, not a singular matrix operation. Okay, the matrix have a size, so you must put identity matrix. You cannot put only 1. Okay, because logically x multiplied by 1 is x, right? But it is not that case in matrix. Okay, so you must put an identity matrix when you use matrix for your equations. Okay, all right. Okay, I think that's all for today's class. Okay, so I hope that you will be able to learn about this chapter, okay, matrix algebra. So if you have any question, you can just WhatsApp me and I will respond to your questions. Okay, so I think that's all for today's class. Thank you.